Welcome to Lecture 2.1 and week number 2 of the course RSC 5040, Energy and the Environment, Green Mountain College. My name is Steve Latender. I want to take a few minutes in this presentation to do a quick tour of the history of human use of energy. And I begin this on this cover slide with an image of a historic photo of Green Mountain College, which of course has been in existence for about 180 years. In that short history of the college, there's evidence across campus of the different forms of energy that have sustained the faculty and students and staff living and working at Green Mountain College. So there are still old fireplaces in some of the older buildings on campus. Of course, cordwood was used for heating, space heating. Back in the old utility building behind campus, there's an old coal bin, so coal would be distributed to campus, delivered to campus, and then burned in a boiler, and then that heat would be distributed across campus. And then today, Green Mountain College is very proud to have invested in a wood chip biomass plant, a modern plant that burns wood chips gathered from local forests, sustainably harvested, and using a gasifying process, they generate heat and then distribute that heat across campus. So again, in the brief history of Green Mountain College, there's evidence of these different forms of energy that have sustained the institution. So let's go ahead and get started. So one of the most important concepts from this part of the course is this idea of surplus energy, meaning you invest energy in a certain activity, and that investment yields excess surplus energy, the energy beyond what it took to do the particular process. And then the classic example would be, of course, agriculture. You invest time and resources in technology, and you're able to produce more caloric energy than the energy that it took to grow and produce that food. So this idea of surplus energy is critically important, and throughout history we see time and time again that there's this very tight link between the availability of surplus energy and the development of complex societies. So the greater the surplus energy, the greater the complexity of the society. And today we live in an era of incredible surplus energy, and perhaps we're at the pinnacle of our complexity in terms of our technology. But even small amounts of surplus energy throughout history have given rise to incredibly complex cultures and political and systems and technologies. And it's, again, an important concept derived from this surplus energy. It's interesting to note also in history, and this is from the Smil reading, that there's some evidence that the drive within humans to acquire a greater surplus or net energy really was a factor in developing our social systems, our social structures. And so this particular example is with humans working together collectively in a hunt that they can generate greater surplus energy than if they were to work individually. So if they work collectively, they can capture and kill a large game, such as a woolly mammoth as an example, again generating a much greater net surplus energy as a group than they would as individuals in hunting. So that's, to me, is a pretty interesting observation that this quest for surplus energy was likely a factor in development of social systems and structures. Okay, as I mentioned, just a moment ago, really one of the critical historical events leading to increasing surplus energy available to society is the advent of agriculture. So this chart here shows about when agriculture started, about 12,000 years ago, and this is per capita annual energy use. So someone has looked at the historical record and developed the data which is presented here in this graph. So what we see over that 12,000 year history, so when agriculture began was really the first process of generating significant amounts of net or surplus energy. There was really a steady rise in per capita energy over this 12,000 year period until the very end of the era that we are in today. So through improvements in technology, through using draft animals, better varieties of species that they're growing, there was this steady increase in net surplus energy available to society. And so during this 12,000 year history, of course, that surplus energy gave rise to some very sophisticated, complex societies. The Mayan culture in the South and in South America, and the Incas, and then of course in Europe, the Greek culture, and a number of other very complex cultures were made possible by this steady, progressive increase in net energy. So as we've replaced technology and other forms of energy for human energy in agriculture, we can see here in this graph there's been a very rapid decline in the percentage of human populations engaged in agricultural production. So in the 1700s, 200-300 years ago, 60%, most people were engaged in agricultural production. And then fast forward to 1900s in England, 10% of the population was engaged in agricultural production. Today, I believe it's even less than that. So this has really been a critical part of the process of surplus energy and humans moving away from the fields to engage in other types of activities, leading to greater social complexity. So it's also important to note this link between this era of incredible surplus energy that we are currently in and the links with population. So this chart here on total human population for the past 12,000 years very much mirrors that chart we just saw a moment ago about per capita energy use. So surplus energy also not only leading to complexity, but also leading to exponential growth in human populations. So more excess energy allows us to sustain more people on the planet. So this final graph here is a graph just showing kind of the modern era, where we are today. So throughout history, most of human energy needs were met with wood. Also, throughout time, there was some contribution of wind for sailing ships and windmills for grain, grinding grains, other processes in water. But by and large, biomass or wood energy was the primary fuel supporting society. And here we are in this 150-year era of the fossil fuel era, where we see exponential growth in the use of fossil fuels, starting, of course, with the steam turbine. So coal was used in a steam engine, and that allowed us to do more work more rapidly. And we've since then developed a host of technologies and systems that use fossil fuels as inputs, which have allowed us to generate significant amounts of net or surplus energy, again leading to greater complexity of our society. So the final slide here, just to touch on these two key concepts that I wanted to get across here briefly in this presentation. The first is this idea of a prime mover. This is the primary technology or systems that meet the needs of society. And so throughout most of human history, muscle was the prime mover. That was, we would hunt and gather, provide caloric energy to drive the metabolisms, and muscle was the primary system by which we accomplished work in our society. And then, of course, that has changed over time, and we moved from human muscle to animal muscle through draft animals, and then as we entered the fossil fuel era, there were new prime movers. The steam engine that was developed was an important technology, representing an important prime mover in the 17 and 1800s. And then to where we are today, the prime mover, the major prime mover is what we call these heat engines that take fossil fuel chemical energy, convert it into heat, and then we exploit the differential in heat in these systems to do work. So the engine in your vehicle is a heat engine. The turbines that are used to generate electrical power Our heat engines, they burn natural gas or coal, creating this heat differential, pushing the steam through a turbine, which creates shaft power, which allows us to generate electrical energy. Airplanes, steamships that sail across the oceans are all driven by these heat engines. So heat engines really is the prime mover of our cultures today. So evolving again from muscle to draft animals to the steam engine, and then today to these heat engines, which are ubiquitous in our lives. And the other important notion is that the history of human use of energy has really been a constant shifting from less energy-dense resources to more energy-dense resources, yielding greater net energy. So if you look at the energy density of a volume, a certain weight of coal versus a certain weight or volume of wood, coal is a much more energy-dense resource. And so we transition from wood to coal, and then we transition to petroleum, which has even greater energy density. And then that really manifests itself today in the highest energy-dense form of energy would be, of course, nuclear energy, where we are splitting atoms in fissionable material and uranium, and that process of splitting atoms yields significant net energy, a tremendous amount of heat that's used in power production today in modern nuclear power plants. So again, those are two real important concepts, trends to take away, looking at human use of energy over time. And with that, we'll conclude. Thank you.